Hello students, welcome back to my channel once again. So today we'll be going with the CBSE grade 10 probability part 5. This is going to be the last part. So in the previous four parts I have explained the probability with different type of problems. So if you have not yet visited those videos, please go through it. Otherwise it will be difficult for you to understand this part. So now let's proceed with this last part, that is part number 5. So first we are going to check the following topics. So today we'll be going solving some problems with this topic. That is a finding the probability of sum based on playing cards. So let us take a look at the question. A card is drawn at random from a well shuffled pack of 52 cards. Find the probability that the card drawn is part number 1 bears a number between 4 and 7, both inclusive. Part 2 bears a number between 3 and 8, both inclusive. So let us take a look how we are going to solve this problem. So we know that there are 52 cards in a pack of cards. So this is the cards arrangement in 52 cards in the pack of cards. So total number of all possible outcomes equal to 52 here. So now we have to find the probability that the card drawn is bear a number between 4 and 7, both inclusive. So both inclusive means we have to consider say 4 and 7 also. So let A be the event that card drawn bears a number between 4 and 7, both inclusive. So numbers between 4 and 7, both inclusive means 4, 5, 6 and 7. So now take a look at the card arrangement. So there are four types of card. In each card we have 4, 5, 6 and 7. So the total number of cards are, so 4 and there are four numbers from 4 to 7 inclusive of both, and there are four types of card as I already explained. So the total number of cards bearing numbers from 4 to 7 inclusive in the black pack of cards are 4 into 4. So in each type there are 4 cards from 4 to 7. So and there are 4 types of 4 into 4, that is 16 cards. So number of outcomes favorable to A will be equal to 16 over here. So the probability of event A is, that is number of favorable outcomes divided by total number of outcomes, that is 16 by 52. Now if we simplify we will get 4 by 30. Now let us solve the second part. Find the probability that the card drawn bears a number between 3 and 8, both inclusive. So let B be the event that card drawn bears a number between 3 and 8, both inclusive. So numbers between 3 and 8, both inclusive means 3, 4, 5, 6, 7 and 8. So that means in each type we have to consider these 6 numbers. So now there are 6 numbers from 3 to 8, both inclusive, and there are 4 types of cards. So total number of card bearing number from 3 to 8, both inclusive in the pack of cards of 52 will be equal to 6 into 4, that is equal to 24. So in B equal to 24 over here, that is now probability of B, that is PB equal to NB by NS, that is 24 by 52. So now if we simplify we will get 6 by 30. Now we will be solving the probability. We will find the probability of sum of based on playing cards. Now the question is, if a card is drawn from a pack of 52 cards, find the probability of getting, one is event A, that is black card, and 2 is event B, that is not a black card, and 3 is event C, a card bearing number between 2 to 5, including 2 and 5. So now let us take a look. So there are 52 cards in the pack. So this is the cards arrangement. Now total number of cards equal to 52 over here. Now in part 1, that is event A, we have to find the probability of getting black cards. So let A be the event that the card drawn is a black card. So now take a look at the card. So how many black cards are there? So we know that spade and club are the black cards, right? So now we have to consider those. Okay. So this is the black cards. So total number of black cards equal to 26, because we know that each type of cards that will be equal to 13. So probability of event A is equal to total number of black cards divided by total number of cards. So that is equal to 26 by 52. If we simplify, we will get 1 by 2. Now coming to the part 2, that is event B, not a black card. So B be the event that the card drawn is not a black card. So not a black card means we know that there are only two cards, right? Black card and red card. So if not a black card means that has to be a red card. So now again take a look at the card arrangement. So heart and diamonds are the red cards. Now each are of 13 cards. So there will be total number of red cards will be 26. So probability of event B is equal to total number of red cards divided by total number of cards, that is equal to 26 by 52 equal to 1 by 2. Now coming to the part 3, that is event C. A card bearing number between 2 to 5 including 2 and 5. So C be the event that card drawn bears number between 2 and 5 including 2 and 5. So now numbers between 2 and 5 including 2 and 5 is 2, 3, 4, 5. So in each type there are 4 type of 2, 3, 4, 5 cards. So now take a look. So these are the total. So in each type there are 4 cards and there are 4 types. So there will be total 16 combinations, right? So the number of cards between 2 and 5 including 2 and 5 is 4. So there are 4 types of cards. So 4 into 4, that is equal to 16. So probability of event C is equal to total number of favorable cards divided by total number of cards. That is equal to 16 by 52. So if we simplify, we will get 4 by 30. Now the next problem. A card is drawn at random from well shuffled pack of 52 cards. Find the probability that the card drawn is a spade. Next part is not of diamond. Okay. So now how we are going to solve this problem? So we know that there are 52 cards, right? So the total number of cards equal to 52. Now we need to find the probability that the card drawn is a spade. So let A be the event that the card drawn is a spade card. So spade card, we know that there are 13 spade cards, right? Second row. Now probability of event A is equal to total number of spade cards divided by total number of cards, that is equal to 13 by 52. So now if we simplify, we will get 1 by 4. Now coming to the part 2. So the probability that the card drawn is not of diamond. So let B be the event that the card drawn is not a diamond card. So there are 52 cards in the pack. Now there are 4 type of card. One is spade, one is club, another is heart, and then we have the diamond. So now there are 13 diamond cards, right? So now here they have asked that that should not be diamond. So that means the raised card will not be the diamond. So if we subtract 52 minus 13, then we will get not the diamond cards. So that means there are 39 cards which are not diamond. So the probability of event B equal to total number of favorable cards divided by total number of cards, that is equal to 39 by 52. So if we simplify, we will get 3 by 4. Now next topic is finding the probability sum based on again the playing cards. One card is drawn from a well shuffled pack of 52 cards. Find the probability of getting a king of red color, a face color, if a face card, and a red face card. Okay. So now there are 52 cards in the pack. So total number of cards will be equal to 52. Now we have to find the king of red color. So let A be the event that card drawn is a king of red color. So now if you take a look at the cards, then how many are king of red color? So first, how many types of red color cards are there? Two types. One is heart and another one is diamond. Now each type there is one king. So these are the two king cards which are red color. So finally there are two kings on red color, right? So probability of event A is total number of favorable cards divided by total number of cards. So that is equal to 2 by 52. If we simplify, we will get 1 by 26. Now let us take a look at the second part. We have to find the probability of getting a face card. Let B be the event that card drawn is a face card. Now take a look at the cards. Now which are face cards? Face cards are king, queen and jack. So each type we have 3 face cards. So there are 4 types total. So that means total number of face cards is 3 into 4, that is 12. So the probability of event B is equal to total number of face cards divided by total number of cards, that is equal to 12 by 52, which is 3 by 13. Now coming to the third part of this question. Find the probability of getting a red face card. So here the red face card means there are two red type of card and face card are king, queen, jack. So there will be total 6 cards because in heart there will be 3 face card and in diamond also we have 3 face card. So there are 3 face cards in each of the 2 red cards. So total number of red cards is equal to 2 into 3, that is equal to 6. So probability of event C is here. Total number of favorable cards divided by total number of cards. So that is equal to 6 by 52. So which becomes 3 by 26. Now we will find the probability of a 4 turning up at least once in 2 tosses of a fair die. Okay. So first question is find the probability of a 4 turning up at least once in 2 tosses of a fair die. So we have to check that at least once the 4 will come up in 2 tosses of a fair die. Okay, so 2 tosses means total possible outcomes are the sample space when a fair die is tossed twice. So how many outcomes are there? Total outcomes, since the die is tossed 2 times, so that means the total outcomes is 36. Now the given event is 4 turning up at least once. So let A be the event of getting 4 at least once in 2 tosses of a fair die. So the number 4 should appear at least once. So either on first die or on second die or on both the dice. So at least once means it should appear at least once, but it can also appear in both the die. So let us check what in where it will appear 4 at least once. So in the first row 1 4, second row 2 4, third row 3 4, fourth row 4 4, fifth row 5 4, and the sixth row 6 4. And if we consider the fourth row, in all the cases we will get 4. But when we have considered 4 4, we should not consider it once again. So otherwise there will be duplicacy. So favorable elements of A are 1 4 2 4 3 4 4 1 4 2 4 3 4 4 4 5 4 6 5 4 and 6 4. So number of favorable outcomes is equal to 11. So probability of event A is equal to 11, that is the total number of favorable outcomes divided by total possible outcomes, that is equal to 11 by 36. Now finding the probability that the helicopter is crashed inside the lake. Okay. So a missing helicopter is reported to have crashed somewhere in the rectangular region shown in figure. What is the probability that it crashed inside the lake shown in the figure? Okay, let us take a look at the figure. So a missing helicopter is reported to have crashed somewhere in the rectangular region. So let us take a look. So it crashed somehow in the rectangular region. Now what do we need to find out? We need to find out the probability that it crashed inside the lake. Right? Now length of the rectangular region, what is given? That is here in the broader length it is 9 kilometer and breadth of the rectangular region is 4.5 kilometer. Okay. So the area of the rectangular region will be equal to length of the rectangle multiplied by breadth, that is equal to 9 into 4.5, which becomes 40.5 square kilometer. Now what is the length of the lake? So outside lake it is given that it is 6 kilometer. So the lake length is 9 minus 6. So that should be 3 kilometer. And the breadth is here 4.5. We know the total. And the in the grass we know that is 2 kilometer. That is already mentioned. So we have to subtract that. So that is 4.5 minus 2. That will become 2.5 kilometer. So the area of the rectangular lake will be, so we need to calculate the length of and breadth of the rectangular lake, that is 3 into 2.5, which becomes 7.5 square kilometer. Now what do we need to find? We have to find the probability that it crashed inside the lake. Okay, so let A be the event that the helicopter would crash inside the lake. So the probability of event A is equal to number of favorable outcomes to event A. So that is the area of the lake where the plane helicopter will be crashed. Okay, divided by the total number of possible outcomes, that is here the area of the rectangular region. So that is equal to 7.5 divided by 40.5. So now if we remove the decimal point, we have to multiply 10 in both numerator and denominator. That becomes 75 by 405. We will get the simplest form as 5 by 27. I hope this problem is clear to you. If it is not clear, just go back and again start from the beginning. I hope it will be clear to you. All the diagram are given. I hope it will be clear to you. Okay. So that's all for today. So this is the last video of probability. I hope you have understood the probability concept now better, and we have solved various type of problems in the probability. So I guess now you can easily appear for any probability question. Okay. So if you like my video, please hit the like button. And again, I'm telling, if you have any question, don't hesitate to put that in your comment section. And please share this video with your friends and families. And please press the bell icon so that you will get notification of the further videos on different topics, and you can learn other topics as well. And that is absolutely free. You no need to do anything, you no need to pay anything. Just you have to watch the video, and please always try to make a note in your copy. Like whenever I am explaining, you also solve with me. So that's my request. Otherwise, until and unless you solve with me, along with me, it will be difficult for you. So while solving, you can take a pause of the video and you can keep on solving the problems. Okay. Hope you like my video. So that's all for today. Okay. Thanks. Bye bye.